The Holocene extinction, otherwise referred to as the sixth mass extinction or Anthropocene extinction, is an ongoing extinction event of species during the present Holocene epoch as a result of human activity. The included extinctions span numerous families of bacteria, fungi, plants and animals, including mammals, birds, reptiles, amphibians, fish and invertebrates. With widespread degradation of highly biodiverse habitats such as coral reefs and rainforests, as well as other areas, the vast majority of these extinctions are thought to be undocumented, as the species are undiscovered at the time of their extinction, or no one has yet discovered their extinction. The current rate of extinction of species is estimated at 100 to 1000 times higher than natural background extinction rates. The Holocene extinction includes the disappearance of large land animals known as Megafauna. Starting at the end of the last glacial period, Megafauna outside of the African mainland, which did not evolve alongside humans, proved highly sensitive to the introduction of new predation, and many died out shortly after early humans began spreading and hunting across the earth. Many African species have also gone extinct in the Holocene. But, with few exceptions, megafauna of the mainland was largely unaffected until a few hundred years ago. These extinctions, occurring near the Pleistocene-Holocene boundary, are sometimes referred to as the Quaternary extinction event. The most popular theory is that human overhunting of species added to existing stress conditions as the extinction coincides with human emergence. Although there is debate regarding how much human predation affected their decline, certain population declines have been directly correlated with human activity, such as the extinction events of New Zealand and Hawaii. Aside from humans, climate change may have been a driving factor in the megafaunal extinctions, especially at the end of the Pleistocene. Ecologically, humanity has been noted as an unprecedented, global superpredator that consistently preys on the adults of other apex predators, and has worldwide effects on food webs. There have been extinctions of species on every land mass and in every ocean. There are many famous examples within Africa, Asia, Europe, Australia, North and South America, and on smaller islands. Overall, the Holocene extinction can be linked to the human impact on the environment. The Holocene extinction continues into the 21st century, with meat consumption being a primary driver of the mass extinction, and deforestation, overfishing, ocean acidification, and the decline in amphibian populations being a few broader examples of global biodiversity loss. Human population growth and increasing per capita consumption are considered to be the primary drivers of this decline. The Holocene extinction is also known as the sixth extinction, as it is possibly the sixth mass extinction event, after the Ordovician-Silurian extinction events, the late Devonian extinction, the Permian-Triassic extinction event, the Triassic-Jurassic extinction event, and the Cretaceous-Paleogene extinction event. Mass extinctions are characterized by the loss of at least 75% of species within a geologically short period of time. There is no general agreement on where the Holocene, or Anthropogenic, extinction begins, and the Quaternary extinction event, which includes climate change resulting in the end of the last ice age, ends, or if they should be considered separate events at all. Some have suggested that anthropogenic extinctions may have begun as early as when the first modern humans spread out of Africa between 200,000 and 100,000 years ago. This is supported by rapid megafaunal extinction following recent human colonization in Australia, New Zealand and Madagascar, as might be expected when any large, adaptable predator moves into a new ecosystem. In many cases, it is suggested that even minimal hunting pressure was enough to wipe out large fauna, particularly on geographically isolated islands. Only during the most recent parts of the extinction have plants also suffered large losses. In The Future of Life, Edward Osborne Wilson of Harvard calculated that, if the current rate of human disruption of the biosphere continues, 1/2 of Earth's higher life forms will be extinct by 2100. A 1998 poll conducted by the American Museum of Natural History found that 70% of biologists acknowledge an ongoing anthropogenic extinction event. At present, the rate of extinction of species is estimated at 100 to 1000 times higher than the background extinction rate, the historically typical rate of extinction. Also, the current rate of extinction is 10 to 100 times higher than in any of the previous mass extinctions in the history of Earth. One scientist estimates the current extinction rate may be 10,000 times the background extinction rate, although most scientists predict a much lower extinction rate than this.